Plate tectonics. Page 5 of the reference table shows all of the tectonic plates, and something you will have to really understand how to use. But first, before we get into this map shows the earthquakes and volcanoes on Earth, and please note that they do not occur randomly. They're kind of in these bands or in these lines, and that's because earthquakes and volcanoes occur at the edges of these plates or the plate boundaries. So if you want to predict where there's going to be an earthquake or a volcano, you really want to find the plate boundaries. That's important to know. Let's look at the three different types of plate boundaries. Divergent plate boundary, the plates moving apart as shown with the arrows. Make sure you know that term. Convergent plate boundary, they're moving together. Transform plate boundary, they're sliding past each other as shown there. And these, you can see on this diagram of page 5, it has the arrows on there. It has the symbols down here for convergent, for divergent. So you being able to use this is important. It's a good reference. Now, one of the key things about plate tectonics is what makes the plates move. What's the force that moves these huge, gigantic plates that are made of rock? You need a lot of force. And what it is convection currents in the asthenosphere. Okay, make sure you know convection currents in the asthenosphere, and that's it's hotter right here. It causes this material of the asthenosphere. It's like this weird, like thick rock that's kind of liquid, but it will then rise because it's lower density. It rises. This area goes over here. This goes over here. Then it sinks. So these are these convection currents here, and the plates are kind of floating on them, and then it causes this plate to move that way and this plate to move that way, getting a divergent plate boundary here. You can kind of see them on page 10 of the reference tables. Inner Earth is a little hard to see here. I'm going to zoom in to the Earth bar. It shows the convection currents here and some of the motion here, though it does not have the term. So that term you need to know. This is how it's shown in a Regents exam question. It shows the arrows of the convection currents here in the asthenosphere under the Atlantic Ocean. And therefore, this motion here is causing this plate to move this way, this plate to move this way, and then you have a divergent plate boundary at the Mid-Atlantic Ridge.